Yeah, guys, we have to win the Calc BC.
L'Hopital. Let's talk about his rule. Okay, this is what you talked about last year in Calculus AB. If we're taking a limit or the value of a fraction, and you get an indeterminate form like 0 over 0 or infinity over infinity, then we can take the derivative of the numerator and the derivative of the denominator and then evaluate the limit, as long as it's not indeterminate. A carrot? Unofficial name?
Oh, that's like, I forget what it's called.
I'm not French, so I don't. Nor am I in French. Or Ecuador.
Oh, that's the dots. Those are the dots. Dots are. Yeah, those are the dots. Deutsch. I should have learned Deutsch.
Okay, so as we're going through these,
Why did you do this year?
No, I just don't like writing. The LIM is mixed with the under, then it gets soft. I don't write so well.
3 years.
Actually, I feel like my test and then
legible? Okay, when you have a limit that ends up being indeterminate, I would like to see that you checked and which kind of indeterminate you have. So if we plug in 0, what do we get here? We get 0 over 0. So I want to see that because I want to see that you then chose to use L'Hopital's rule. So this is the same thing as the limit as x approaches 0 of, since it is 0 over 0, we could take the derivative over the derivative. And now, what is our limit? You can say it louder with confidence. You don't have to whisper. 3.
I had 100% confidence.
Why do you whisper?
Jamie just finding himself. We have this issue in English class. Right? Yeah, and Jameson likes me before. That's right. Does he like you?
Mr. Anderson doesn't like Isaac?
No, he does.
I find that hard to believe.
He doesn't like. I think he doesn't like the quiet.
Teachers don't like have it out for kids. Okay. I
know some people do.
I don't. Let's talk about this limit. The limit as x approaches infinity of natural log of x over 2 radical x. What happens towards infinity of natural log of x?
Oh, wait.
Infinity. And what about 2 radical x? Okay. Indeterminate. Are you confused about what's graphs? Natural log looks like this. Remember it.
No. Like
Yep.
summation, like you had 1 plus 2.
Okay, so to use L'Hopital's rule,
That's the right answer.
derivative of natural log
1 over x. Times.
divided by derivative of 2x to the 1/2. Okay, we can just look at it like this, can't we? Well, no, we can't. We have to rewrite it. So what did you say it was the same as? Square root of x over x, or 1 over square root of x?
Yeah. What? You just cancel.
Or you could just, oh,
So,
we don't do
okay. Are we all okay that this is square root of x over x?
Yeah.
So this is the x to the 1/2 power and x to the 1 power. So when you reduce them, we're left with the 1/2 power downstairs.
Yeah.
Okay. And as x goes to infinity, what happens to radical x? Goes to infinity. And so when we have 1 over radical x, this would go to 0. Smiley face.
1 over square root of x.
Awesome.
Are you sure? Is that a smiley face?
That's what our teacher. You could write 2 smiley faces on each side. Or you can make it the eyes. Oh. Turn the concavity of that frown upside down.
Love the math language that you are.
Stop using
Okay, next example.
I'll stop using
So I told you my son has to get glasses, right?
Nope.
My 3-year-old has to get glasses. They're ready today. He picked out red frames, like Husker red glasses. So yeah, 3 years old. We have like those rubbery ones that are like bendable.
Eli used to have to go and get his once a week.
Well, and that's what we're trying to avoid. We know that brothers like to.
Oh,
He just didn't take care of him. That's what happened.
Well, my kids like to wrestle each other. Okay, if we tried to evaluate this limit, we would get infinity over infinity over infinity.
Yeah.
We don't know. They're not doing that.
Let's talk about e to the negative x. This is e to the x. Therefore, this would be e to the negative x. Knowledge that you need to have up here to visualize or draw. Get it out.
Am I the only person that can remember?
You gotta be able to do this without your calculator.
Yeah, it's
Oh, gotcha. Okay, so can we use Hope's rule?
Oh, yeah, how's that not 0? Isn't that freaking 0?
Because it's negative infinity, so it'd be...
Oh, it's negative infinity.
Oh.
Yeah, it's a negative, it's not a 0.
We're actually creating.
Okay, so we would have 2x over negative e to the negative x when we apply L'Hopital's rule. Well, now we have negative infinity over negative infinity.
Again.
Okay? We can use L'Hopital's rule as many times as we need to, as long as it is necessary. Remember, it has to be indeterminate in order for us to be able to use L'Hopital's rule. So we do it again, that's perfectly fine, and we get 0. Okay? Now, I'm going to blow your mind. These are not the only 2 indeterminate forms.
That was like 9. There are a lot of confusion with the 0.
How do you know that? How many there are?
He told us.
Oh.
Oh.
So there's actually 7.
That was my next.
1, 2, 3, 4, 5, 6, 7. You must know them all. I bet that'll be a quiz question.
I bet it wrong.
0 to the 0.
I don't know.
I don't know what that is.
Well, I was
Nope.
watching something. And it's, no, I wasn't saying it existed, but if you like look at the regular plane, it act like you can approach a point, but if you look at the complex plane, it gets messed up. That's the reason.
Okay. Well, and if we think about it, we know 0 to a power is 0, but we also know anything to the 0 power is 1. But there's 2 different rules combined into 1. Yet, 1 to the infinity.
Can it be any number to infinity?
No, only 1.
Well, there's no.
Because typically we say 1 to any power is 1, but we also say a number to infinity is infinity. So there's two different contradicting rules happening at once. Infinity minus infinity, why is that indeterminate?
Subtract
Because
something.
infinities are neither bigger nor
Anything
smaller.
subtracted from anything.
Okay, they're just in a they're like a concept, right? Some infinities could be bigger than other infinities, but we have no way to tell that. Okay, 0 times infinity. Contradicting rules again. We like to say anything times 0 is 0. We also like to say anything times infinity is infinity. No. And then infinity to the 0. We like to say infinity to the power would be infinity, but we also like to say anything to the 0 power is 1. So contradicting.
All of these things just don't have an answer?
Correct.
That's what
Wow.
Yep.
That's what like a barrage econ of these questions.
Ooh.
No, he's
Jake and Isaac.
He said barrage.
Econ.
Isaac, tomorrow in econ, we're gonna ask them all these things and see what they say with the answers.
Mr. Gomez?
No, like the people in our class are around.
Oh, yeah. He's gonna say, you need to 86 all of those questions.
Okay, are you ready to see some examples?
I'm
Okay. No.
Yeah.
Pretty much,
Why is it 0?
we can only use L'Hopital's rule if we have 0 over 0 or an infinity divided by an infinity. But these are all indeterminate forms. So if we can take these indeterminate forms and rearrange them to be that 0 over 0 or infinity over infinity, then we can use L'Hopital's rules that way. Does that make sense?
Wait, why isn't 0 to infinity not a can't pronounce it.
Indeterminate?
Hidden form.
I think all these have an answer.
What about zero over infinity?
Yeah, most of them are 0.
Is 0.
0 to 0, yeah, that's just.
0 divided by an infinity is 0. Yeah.
What about infinity divided by 0?
No, there is a proof. Do I have the proof? There is a proof. I'm not sure I have it. There is a proof. It might be in your book.
What's
We can look
infinity
at it
divided by 0?
at the end. Infinity divided by 0, undefined. You can't divide by 0.
Is it indeterminate or is it undefined?
Why is it
You can divide by 0 in that form.
No, you can't. It doesn't make it. That's not an answer. It just allows you to use.
Yeah, but it's the indeterminate
Make it
form.
into a fraction.
What's 5 cubed is 625, right? When you divide by 5, we get 5 squared to be 22.
No, it's not 6.
Okay, sorry. I was thinking to the 4th. I was going to write the 4th and then.
Whoa. Whoa.
And we can keep going. 5 to the negative 1 equals 1/5. 5 to the negative 7 equals 1/5. Okay, so Peter, we'll cycle back to your question, okay? But I want to get some examples done in the 25 minutes that we have. Okay, remember, if it's indeterminate, we need to find a way to make it a fraction in order to be able to apply the L'Hopital's rule. So, if we tried to do this, e to the negative x looks like this. Towards infinity, we approach 0. X squared towards infinity, we approach infinity. We have 0 times infinity. Indeterminate. Okay? So we have to apply the L'Hopital's rule. Now we can't unless it's a fraction. How do we make it a fraction?
Let the e to x.
Okay, so we're going to make this the limit as x approaches infinity of x squared divided by e to the x. you'll notice now that we have infinity over infinity, still a L'Hopital's rule, right? So we have 2x over e to the x, which is
Still infinity over infinity.
infinity over infinity. So then we'll have to do the limit as x approaches infinity, L'Hopital's rule again, to get 0 as our limit.
When we do it on the test, you want us to show L'Hopital's rule every time.
Yes. Just so I can follow your work. I had a student who would draw an ambulance every time he did L'Hopital's rule.
Did you enjoy his art?
He drew very nice ambulances.
How long did it take him?
He was always the first one done with his tests, so it didn't matter. Graham Brooks.
Who's always the first one done here? Not me.
Okie dokie. What do we got?
Is that 1 to the right plus?
Yep, one on the right.
What's the last one?
Oh, to the right.
So 1 to the right of natural log of x, that would be 0. And here we have an asymptote at 1 towards the right. It's going up towards infinity. So we have infinity minus infinity. Okay? How will we get this to be a fraction? Common denominator.
How is it possible for some infinities to be bigger or smaller than others?
Oh, watch Vsauce, watch that, and then watch how to count. Well, there's like 3 videos about infinities, and then just watch.
They're my favorite.
How about on the Calc chat, you will text that video to the group so they can watch it.
They're wonderful. It's like 20 minutes.
Okay.
20
But the
minutes long,
smallest infinities, alpha null, just remember that.
though.
Okay.
The biggest.
So, like, do you agree, hey Jake, do you agree that some functions grow faster than others?
Well, they don't actually have biggest features.
Okay, so some functions are going faster towards infinity than others, but they're all going towards infinity. But we can't, like, determine, like, this one's bigger than the other. We know that they're not equal, okay, but we can't determine where they're big. Does that make sense?
That's okay.
Okay.
Think about like if you had a set of stuff that went to infinity, and then you had another set of stuff that went to infinity.
So like it's like all of the
And
you have
those
1, you have 2, you have 3, so on to infinity. But then like you have 1 and then like 1.5 and 2 and then 2.5. Like that's
But
a
they're
bigger
both
infinity.
infinity.
But they're
Actually,
both
I
infinity.
don't
Yeah.
actually know if that's technically counted as a bigger infinity.
Okay, what were you asking me? I think.
Because you're
I'm the ultimate woodworker in 4,000.
like the small, or like a big infinity would be going from 0 to
You're the
1
ultimate what?
with all real
The
numbers.
4th hour?
Yep.
Congratulations.
With the broken wrist.
With the broken wrist.
Oh.
Here.
With a broken wrist. Like you're the
No,
ultimate
no.
broken wrist woodworker?
No.
Or you're the ultimate woodworker even though you have a
Even
broken wrist?
though-
Gotcha.
There's something-
Okay, so we are making common denominators so that we now have the limit as x approaches 1 from the right of x minus 1 minus natural log of x all over this stuff right here. Ugh. Okay. So that looks pretty terrible, right?
0 over 0. Yay.
Is 0 over 0, and some of you are going to get to this point and you're like, okay, well, I know that it's L'Hopital, I know that it's indeterminate, so even when I rearrange it, it's going to be indeterminate. Don't feel like you need to check it again, okay, until you do L'Hopital's rule again. So let's do L'Hopital's rule. Let's see those deriving skills in action. Okay, and then we have some,
No.
product rule action going on here.
Whoa.
Okay? Now what are we gonna get? Zero over zero, right?
Yeah. Zero.
Yeah.
Done?
No, this is a bad one.
Oh, it's gonna be just fine. We can take the limit again, can't we?
Oh, it's not.
So, let's see what Hopkins rule again. Derivative of 1 minus 1 over x.
0.
1 over x squared.
1 over x squared.
Yep.
Alex, did you get your question answered?
Yeah.
Okay. Our denominators, derivative of 1 is 0. Derivative of x to the negative 1 is going to become a positive x to the negative 2.
Yay. It's all over.
Is it all over?
Yes.
Because what do we get when we plug in 1? Amazing.
I was like, they're all ones. And I was like, answer's one.
Oh, a question that you can ask.
Yep.
Why do kids this year get their driver license but we never got ours?
It's just something we started this year.
I wanted to ride her like.
I am so sorry.
I'm not legally licensed.
But that means I can't do derivatives anymore. I'm not allowed to.
Well, maybe you'll have to earn it.
There's a licensing fee.
I'll think about it
Wait, we have to earn deriving, but we've like,
by the end of the week.
We need like derivatives and
Can you write this down? This might be one of the more important examples that we do today.
This is the last one.
Sure is not the last one. And to keep the chit chat. What are you guys talking about?
We're talking about what the ingredients stand for.
Okay. If we try to evaluate this, we're going to get 1 to the infinity.
Now, 1 plus 0 to infinity. We have to make this equal.
You always want to try plug it in right away, right? Okay. So, we'll have to rule. How the heck are we going to make that a fraction?
1 to infinity is 1. It's 1.
Not.
It's 1 multiplied
No.
infinite amount of times.
Yes.
Yeah.
Yeah, so what is just be one?
It's never going to change.
It'll always.
There has to be something that is something
What do we know about e raised to the natural log of x?
like X.
Okay.
Yeah.
So if we take e to the natural log, it's like being redundant, right? They really cancel out.
Yeah.
So why would this be helpful?
Because we do it to everything.
Ah.
Good one.
Then we just get back to the original thing.
Whoa.
Hold on.
Oh,
So I have done this. Now, if we have a function with a limit inside, right? We basically have a composite function with that limit. We could rearrange for this to be the limits as x approaches infinity of the natural log of 1 plus 2 over x to the x. Now, can you see where this is going?
How do we
Yeah, you
do
can't. What? Good one. Yeah, I just switched these. The natural log of the limit is the same as the limit of the natural log.
And then you put the x in front.
And then you can put the x in front.
X from it, it goes to the first, and then it's x in the first. Science. This is what they told us in physics 2 last year. So I'm taking like x maybe 1 plus 2 over x. Having infinity,
So now we have infinity times 0. We still need to make it a fraction. How do we make that a fraction inside the limit? No, we want to leave the natural log of 1 plus 2 over x. We will leave that as our numerator, but then we're going to divide by x to the negative first. Now we have a fraction in our limit. Do you see that? See how I did that? I've never known math to have so many giggles until this class. All right, so let's L'Hopital this guy.
0 on the bottom.
No, because there's that
Right?
What?
0 on the bottom?
Yeah, so it's 0 over 0 now.
Yeah.
Yeah. Which was the whole, we knew that was going to happen though, right?
Yeah.
Okay, we knew from the beginning we had an indeterminate form. So now we've rearranged it to be able to use L'Hopital's rule. It's still indeterminate. Okay, now let's actually do it. 1 over 1 times its derivative over denominator's derivative.
What's in the denominator on the left? Fraction?
It's still the same. It's still the 1 plus 2 over x. Okay, so can we reduce this a little bit? The negatives cancel, right?
Yeah.
These x squareds cancel. And we are left with
1 over 1.
2 over 1 plus 2 over x. Right? That 2 is still there?
Yeah.
Okay. Well, what happens as the limit as x approaches infinity of x over 2 over x?
0.
So we have e to the power of 2.
Is that about 14? Conversation.
Creative way to pull that out.
is the limit to.
But no, e squared is not 14.
The limit is 2, but it's e to the left.
So the limit is 2, but since the e is still there,
4 point something.
it's e to the 2.
So if you're just solving for the limit, you can write e to the 2 or we can solve.
Well, the limit of our original guy was e to the natural log of the limit,
Okay.
right?
Yes.
So that e stayed along for the ride. Originally, the e was canceling out with the natural log, but what we did, we used the natural log, so now we're stuck with e to the 2.
So the limit is.
The limit is e to the 2. Yes. You didn't have a, Nick, did you have a question? Yes, I'll come back to you, Nick. The e came from all the way up here, where we put this limit inside e to the natural log. E to the natural log cancels out, right?
So why, like, how do you know, like,
Okay, we are gonna do that if we have an indeterminate form that involves a power, right? Do you see how our power was x? So by doing this, we could use the properties of logarithms to take that power and move it out in front.
Maybe it's a problem.
And then we could write it as a fraction to be able to use L'Hopital's rule.
Okay, and then what happened?
Here to here,
No, so we're not here.
here to here, we took derivatives. So the derivatives of the natural log is 1 over blah, blah, blah. And then chain rule, the derivative of 2 over x would be this. And then over derivative of the denominator there.
Oh.
So we actually applied L'Hopital's rule there. Do you see what I'm saying? Should we do another one like that? We're gonna do another one.
X.
This this is not as painful.
It's only slightly.
It just looks weird. It looks like it's not allowed now.
Thanks.
You find something to help you out there?
Yes, maybe extreme.
E to the natural log of x to the x.
I do want to tell you that the definition of the number e is the limit as x approaches infinity of 1 plus 1 over x to the x. That is the definition of the number e.
Why?
Well, we could take the limit and I could show you.
Wait, is that how?
Finding that?
Wait, is that how like the full PERT formula came to be? Because you're using PERT, you're like always accumulating.
What's so special about the number 2.7? Because
It's magical.
it's math.
Is that, yeah, I mean, it's that. I mean, that's what it is. That's why it's magical.
Yeah, but like, I could plug in like a random equation like that, and I could get like 9.8, and I'm gonna be like, I'm gonna name that L.
Or J.
Or J. Or big J.
Okay. There's a lot more than just that to the number e.
That's what I mean. It doesn't matter.
It's like
Okay.
pi, but like.
We have 0 to the 0. Not 0 degrees, but 0 to the 0. Okay? So, anytime you have the 0 to the 0, or the 1 to the infinity, or infinity to the 0, you're going to use the e to the natural log. Anytime you have that exponent case. Alright? So, e to the natural log of the limit as x approaches above.
E to the x.
Okay, so e to the natural log cancels out, but we are going to switch the limit and the natural log so that we can write x, natural log of x. So now it's no longer in the exponent. However, now we are stuck with 0 times negative infinity. Okay, that is still indeterminate. We cannot use the L'Hopital's rule until we make it a fraction. Natural log graph looks like this. Okay, so we would have to write this as the natural log of x over x to the negative first. That is how we would make that a fraction. It is okay to forge negative powers as long as it creates a fraction for L'Hopital's rule. Does that make sense?
Natural log of 0 over 1. Whoa.
So now we have infinity over infinity, or negative infinity over infinity. Okay, so
Negative infinity over negative infinity?
I'm confused.
positive infinity.
Is that one of the rules? Is that so
Infinity over infinity is not okay, whether positive or negative or a mixture. Okay, order to do L'Hopital's rule, we have it as a fraction. Infinities over infinities, doesn't matter if it's positive or negative, but we have indeterminate. So now we can finally take our derivative. How important is it to reduce after you take the derivative? Pretty important, otherwise you're going to get stuck in a terrible cycle. 1 over x divided by 1 over x squared.
It's like
No.
Nope.
It's negative.
I tried.
That's 0. Negative 0.
Negative 0.
One.
Our limit is 1.
Yeah, it's just
You was number 1.
well, then
Are all of these answers going to be good
Nice.
numbers?
Yes.
We're talking
How
about.
does this tie into the other stuff?
Well, it really doesn't until tomorrow when we look at improper integrals. We need L'Hopital's rule for improper integrals, which is like the icing on the cake. Now, you don't have to write this down, but this is a L'Hopital's rule problem 1.
because it goes
Does that equal like 0?
Zero.
If we put 1 in here, the integral from 1 to 1 is
0.
over
0.
0. So if we use L'Hopital's rule, what
like
is?
cosine
Cosine.
Ah.
over 2x.
The derivative of an antiderivative is the function that's inside.
Yeah, it is. And you just put it.
Those are going to get ugly, aren't they?
They're gonna get
Now, you guys have to practice, especially the ones with the power, okay? Because that just takes some getting used to. Okay? Homework, 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 homework.
Coleman,
Yes.
according to the TO-89, 1 to infinity is 1. Infinity is 0 is 1, and 0 is 0 is 1.
the calculator knows all.
Well, it is indeterminate.
I guess that means you won't be able to use the calculator number.
There's got to be longer words and stuff. Right?
Oh, Peter, where did,
Gone.
in our,
Yeah, yeah, I don't know. Your answer.
are we gonna show him
Oh, what?
the proof for L'Hopital's rule? You're gonna find it for him.
Like, what do you want to do?
No.
Does that feel weird? You're going home? You haven't done that all year.
Except one day. Because we have a Thursday game.
And Friday is your practice. Nick is going home?
Because everyone on our team was hurt. No, I can't.
Good working. Okay.
You can play. I can go to hunt. That's dangerous. Someone runs into it. Hopefully.
And this is like 1 over x and 1 over infinity would be 0, which is the same thing as 1. X to the negative 1 means 1 over x. Better?
Yeah.
Whew, okay. Oh, I'm still recording. If you made it this far, the code word is... Everyone was here today. Huh?
86.
86. Code word 86.